So, good morning and welcome on the webinar focused on the totally new feature for version 10.9. It's fire resistant of concrete structures. Let me introduce presenting Orsolia Kartali, our product engineer.
Hi.
And me, I'm also product engineer Lukas Juricek. So we are using a platform GoToWebinar, and you can see on the right side that you can type in the questions or your question during the webinar, and we will answer that during the webinar or after the webinar and send you the response. So some agenda. Orsolia will explain and describe the method how to calculate and calculate and check the concrete structures from the point of view of the fire resistance. It will be focused mainly on the columns, beams, walls, slabs. Yeah. So Orshi, I pass the word to you and you can start.
Thank you very much, Lukas. So, as Lukas was saying, we will go through all the points of the fire resistance check, which is a new feature in our application RCS and in the product concrete and prestressing. The first point that we will discuss is the load effects during a fire. How should the engineer decide which load effects are acting during a fire situation? According to Eurocode, if you open the code, the part for the fire resistance check, you will find a quite complicated method for calculating the load effects during a fire, but there is also a simplification that engineers can use, which is a recommendation that we can assume that the extreme load effects during a fire can be considered as 70% of the ultimate limit state load combination. This simplification for us means that in the environment of the application RCS, where we need to fill in a table with the acting internal forces on the cross-section, we just simply calculate the 70% of the values from the first row, which is the ultimate limit state combination, and fill those values into the new row, the last one for the fire resistance. I will show how it is done in the application. Let's go through some of the basic assumptions of the tabulated data method, what we should acknowledge before we start checking something according to the tabulated data method. What are the limitations and what to keep in mind? All values that are described in the tabulated data method are primarily for concrete with siliceous aggregate, which is most prone to fire damage. If you are using concrete which has carbonate aggregates, it is possible to reduce the recommended minimal values by code by 10%. This is something that is done in the background of the software. You just have to make sure that you have the right concrete setting and you choose the right aggregate which will be in the concrete that you are checking. The humidity of concrete must be lower than 3%, otherwise explosive spalling of concrete may threaten. This is something that you have to make sure as an engineer that it is written in the product documentation because this is one of the basic assumptions of the tabulated data method. The critical temperature of regular reinforcement is 500 degrees Celsius. For pre-stressing reinforcement, this temperature is considered 400 degrees Celsius for pre-stressing bars or 350 degrees Celsius for tendons. The axial distance of reinforcement from the surface of the cross-section must be lower than 70 millimeters. Otherwise, some of the surface parts of the concrete can fall apart during a fire. So if you cannot make sure that this distance from the outermost layer of the reinforcement is lower than 70 millimeters, if you have to consider a higher value of concrete cover, then you have to make sure that there is some surface reinforcement in addition to the bearing reinforcement. In case that you have several reinforcement layers input into the cross-section, this axial distance is calculated as an average of all layers, where the outermost layer must fulfill the criteria for at least R30. What this R30 means, we will discuss a little bit later. It basically means that the cross-section can stand 30 minutes of the fire, and still it maintains its load-bearing capacity. We can interpolate between the tabulated values linearly. Again, this is something that is done in the background of the software. The tabulated values should be considered as absolute minimal values, and you should still respect all the detailing provisions according to Eurocode. So if you are checking a cross-section and you are checking not only the fire resistance but also the detailing, then you are on the safe side and all the conditions will be met. Some basics of the fire resistance. The resistance types that we know are basically 4 types: resistance type R, E, I, and M. But what do these letters really mean? The letter R stands for the load-bearing function of the structure or the structural member, which means that during a fire, you want to maintain the load-bearing capacity, the load-bearing function of the given member. E stands for integrity, a separating function. This is a resistance type that can be considered for walls or slabs, which have a separating function between separate areas in a building. I stands for thermal insulating function. This is again something to consider for walls and slabs. And M is a special type of resistance. It is only for firewalls. So let's go through the basic structural member types that we can code check with the tabulated data method, which are the columns, beams, slabs, and walls. And let's see some specific settings for columns. According to Eurocode, we can use 2 design methods, method A and method B. The engineer can choose one method or both methods are performed. By default, in our application RCS, both the method A and method B are performed, or if you want to choose one of the 2, you can do it manually. The tabulated data method can be applied for columns that are loaded preferably by pressure. And it is important to know that it can be used only for braced structures. Some restrictions or properties of the method A described in the code. Method A can be used only for columns that have maximal effective length of 3 meters. The effective length is calculated from the total length of the column, and it is calculated differently for columns that are positioned on the top floor of a building or in any other floor of a building. So for top floors, the effective length is 0.7 times the total length of the column, and for any other floor in the building, it is 0.5 times the total length. The eccentricity E0 of the column must be lower or equal to 0.15 times the height of the cross-section. The maximum amount of reinforcement, AS, is also limited. It should be less than 4% of the whole area of the cross-section. The method B described in the code doesn't have such or so many restrictions, but it can be used only for braced structures, and the effective length of the column can be over 3 meters. If you want to design and co-check columns, cross-sections of columns using our application, it is important to set right the column length, the position of the column in the building, if it is on the top floor or another floor in the building. You have to choose the correct fire resistance, which can range from R30 to R240. Now we know that this letter R stands for the load-bearing capacity, because for columns we always have to maintain the load-bearing function of the structural member, even during a fire. And we also have to set if the fire affects from one side of the column or more sides. So let's go to the application, and I have already prepared some examples for each structural member type. For example, here is a project for columns. If you are new to IDEA StatiCa, how you get into this environment of the application RCS is that you open the basic starting window of IDEA StatiCa. You go to the tab Concrete, open the application RCS, which stands for Reinforced Cross-Section. Here we can design and co-check reinforced and pre-stressed concrete sections. And if we create a new project, besides choosing the right code and right annex that we want to use, we have to check the checkbox for fire resistance. And after that, we choose which section type and member type we want to analyze. It can be a beam, a compression member, a column, or even some 2D members as walls and the slabs. And the cross-section can be also pre-stressed, which would be this option. So by clicking OK, you would get into this environment of the application RCS, where you can input cross-sections, reinforce them, and co-check them according to Eurocode or another code that is implemented. So for this column example, I prepared two cross-sections. First one has a rectangular cross-section, and the second one has a circular cross-section. And I will show you what is important to set going step by step through the navigator, as the usual process is, and what are the special settings for fire resistance. So right in the part of the cross-section, which is the first step in the navigator, here we can set the material, the concrete material for the cross-section. By clicking on the Edit button of the material, we can display the detailed settings for concrete, and here it is important to set the right aggregate type. We have four types, and as I mentioned, the basic values from the tabulated data method are set for siliceous type of aggregate. If you have carbonate type, then the values can be reduced, and if you set the aggregate type correctly here, the correct values will be considered in the code check. So we don't have any pre-stressing in this cross-section, so we can skip this step and go to the design member. In the design members tab, in the second tab, imperfections and second order effects, we have to correctly input the length of the compression member, the total length, and how the effective length will be calculated. I will leave it as according to supports. it is important to set correctly the supports on the beginning and the end of the column, and the column position in the building, which can be other floor or top floor. Let's consider now other floor. And we can go to the next step of the fire resistance. So you can see that the checks are performed according to the tabulated data method, and I have chosen the method B for the check of this cross section. But if you start a new project, by default you would have A plus B always set here. So when performing both methods, the application calculates if the column with its settings qualifies for both of the methods, and takes the worst choice of the two, or the engineer can choose on their own which one they want to use. The resistance type can be set from R30 to R240. For columns, it doesn't make sense to use the resistance type E or I, because none the integrity, the separating function, neither the thermal insulating function doesn't make much sense for columns, only the load-bearing resistance type. And the fire effect can affect the column from one side or more sides. Going to the second or next step, internal forces, we will see a table where the acting internal forces are displayed on the cross-section. I have some values for the ultimate limit state combination for all types of internal forces, and I will simply multiply these values by 0.7 to get the 70% value of the ultimate limit state, and these are the values that I will fill in to the last row for the fire resistance, simply as it is. In second order effect step, there is nothing special setting for fire resistance. And in reinforcement, also you would reinforce the cross section as you would do it usually, using a template or some user-defined reinforcement. In the calculation control, it is important to have the checkbox checked for fire resistance, and then we can go to the results and see in the last tab of the fire resistance check the results of these checks. The first thing in the table is the acting load effects on the cross section and the value, the final value of the utilization for fire resistance. We have chosen the method B. So here are the check provisions for the use method B. And all the symbols that you see here, which are checked on the cross section, are described, explained down below in the explanation. So we are checking the cross-section dimensions, the axial distance of the layers of reinforcement, and so on. In the non-conformities, you can see also maybe some warnings if there is something to warn you about, or some additional information. For example, this thing that the cross-section contains concrete with the limestone aggregates, and because of that, the minimal dimensions of cross-section are reduced by 10%. This is a recommendation by Eurocode. Okay, let's check out the second section, which is mostly the same as the first one, just it has a different shape. It has a circular shape. In cross-section, we can check out what aggregate type we have, different than before. In design member, there is a same complete or total length of the column, but the column is positioned on the top floor of the building, so the effective length will be calculated differently. Fire resistance is calculated by default by the method A plus B, and the resistance is set as R120. Internal forces as usual, and the results are very similar to the one before. We are controlling the dimensions of the cross-section, the axial distance of reinforcement from surface, and other values. So let's go back to the presentation, and let's go to the other member types. This one will be for beams. So what are the specific settings if you want to co-check beams for fire resistance? We, by default, in the application RCS, are able to check the cross sections which are rectangular, T and I shaped for fire resistance, and the separate parts of the T or I shaped cross sections can have a hinged part, for example, as this T section or this I section here. Eurocode defines different parameters for simple span and continuous beams. This is why it is very important to set the type of the beam correctly, if it is simple span beam or if it is continuous. And for continuous beams, even the position of the section that we are checking at the moment have to be set correctly. If it is somewhere here, or over a support, or between supports, or over a second support. Let's check this out on a practical example. This project was also prepared for demonstration with beam type cross sections, and this setting where you define where the cross section is positioned is here, this position location. And if you go over it with the mouse, this picture appears that helps you understand how to set the position correctly. So the first section is a section on a simple span beam. The second section is on a continuous beam, but it is placed in the span part of the beam. And the third section is on a continuous beam, and it is over the first intermediate support in the green area marked with the C letter. Again, we go through the navigator, and in cross section we set the correct concrete material with the correct aggregate type. In design member, we should go into the second tab, flexural slenderness, and set the length of the beam and whether the support on the left and the right side are then continuing, if it is a continuous member after the support or not. Then in the step fire resistance, we also have to set the resistance type. It is similar as the columns. We only have the resistance type R for load bearing capacity, and the fire effect if it comes from 3 sides of the beam or all sides. If we have a floor above the beams, we can consider it to internal forces. The same rule applies, that we have to consider 70% of the ultimate limit state values for fire resistance. And we can go to the results and check out the fire resistance results in the last tab. So we are checking the B value, which is the beam width, the axial distance of the outer layer of reinforcement from the surface, minimum slab thickness, and so on. If you have a cross-section which is, for example, a T-shaped, there is a separate slab type of part and a separate beam type. And the rules for slabs and the rules for beams are applied on each part of the cross-section. The other two sections are basically the same. They just have a different position location on a beam, which then has an effect on the values, on the limit values that have to be taken into account when checking the cross-section. So we can go to the next member type, which are the slabs. Slabs are 2D members, horizontal 2D members, and we also have some specific settings for them. Similarly, as beams, we have to set if the slab is single span or continuous, and if the slab is supported by walls or columns, because this also has a big effect on the check values, if it is locally supported or supported by walls. The engineer also has to decide if they consider a moment redistribution below or over 15%. This has to be set manually in the application. And we also have to input the length of the slab in both directions. These are the examples how such slabs are described. We can have single span one-way slabs or single span two-way slabs, or continuous slabs which can be supported by walls or supported by columns. In all these steps, it is important to set the length in the X and in the Y direction. Let's go to the practical example. Here I have a section of a slab which is defined in the cross section with its thickness is 200 millimeters and the concrete material. Again, let's pay attention to the aggregate type. In the step called the design member, we can go into the second tab and here set if the static system is one span slab and if it is one way or a two-way slab, or if it is continuous and supported by walls or columns. Moment redistribution can be less than 15% or more than 15%, and the length of the spans can be set here. I will consider one span slab, which will be a one-way static system. In the step fire resistance, we have a little bit different resistance type. You can see that the resistance type E and I are appearing here because slabs are dividing, separating the floors from each other, so they have to maintain their separating function and also their thermal insulating function besides the classic load-bearing capacity. Internal forces, we have a slab type internal forces here, but the rule remains the same. We multiply the ultimate limit state values by 0.7 and fill them into the last row for the fire resistance. In the reinforcement, we would reinforce this slab in a classic way, the upper surface and lower surface. And in the results, we can immediately see the results for the fire resistance and what is controlled on this section. It is the minimum slab thickness and the axial distance of reinforcement from the surface. Okay, and we came to the last part of the practical demonstration. It is for the walls. What are the specific settings that we have to consider for walls? So according to tabulated data method, the ratio of height and thickness of the wall should be less than or equal to 40 to avoid excess deformations. If we have a more slender wall, we unfortunately cannot use this simple checking method, and we have to go for more complicated methods for fire resistance. Here we can consider separately resistance type EI, which is for integrity and insulation without load-bearing effect. If we have a wall that is no bearing or just dividing some parts of the building, or if we have a load-bearing classic wall, then the resistance type REI is considered for load-bearing, integrity, and insulation. For walls, there is a special criteria, M, which stands for firewall. If we want to check the wall for this M criteria, there is a limit for thickness. The thickness of the wall has to be at least 200 millimeters for non-braced walls, 140 millimeters for braced bearing walls, or 120 millimeters for braced non-bearing walls. And the fire can affect from one side of the wall or two sides of the wall. Okay, I will show the last example in RCS. This is one section of a wall. Very similarly as the slab was before, we set the thickness and the material, and we go to the design member, where again in the second tab in the wall, we have to set the height of the wall correctly, and from the thickness of the wall and from the height, the slenderness is calculated, and the application can decide whether it can perform the check for fire resistance according to this method or not. In the fire resistance tab, we have much more resistance types than before, because we can have non-bearing walls and bearing walls, and for non-bearing we don't consider the resistance type R. The resistance type M, if we want to consider the wall as a firewall, then it has to be checked in this checkbox, and we can check the fire effect from one side or from two sides of the wall. Internal forces are again just 70% of the ultimate limit state value, and in reinforcement we would reinforce it simply as the upper surface and lower surface of the wall, and in the results go to the fire resistance tab, and we can see that the slenderness of the wall was checked here. The ratio of the height and the thickness of the wall was 20, so it is way below 40, way below the limit value, so it is okay. The resistance type M is also fulfilled because we have the thickness of the wall 200 millimeters, and the limit value for this type of non-bearing wall would be 120 millimeters. Okay, so this was the last member type that I wanted to show you. I will give the word to Lukáš and ask if there were any questions during the webinar that we should answer.
Yeah, thank you, Orshi, for a very exhausting explanation of the fire resistance check of the concrete members. I've got or received some questions from the audience too. The question is there a possibility to do a code check using tabulated data method for beams with general cross-section?
Thank you. This is a very good question. Yeah. So the tabulated data method in Eurocode has its limitations, and because this is right now the only method implemented in our concrete applications, we have to go according to these limitations. And in the method, there are only the rectangular, circular, T-shaped and I-shaped cross-sections described, so we cannot really go into more complicated shapes. The only thing that we can do is we can consider hinged parts of these beams, these T and I-shaped cross sections, but since the method has its limitations, we only consider these 4 cross section types.
Yeah, great, Orshi. Thank you for answering. So we'll continue. Please, after webinar, fill in the short survey formula, and the recording will be available till 3 days in the section webinar on our webpage or on our YouTube channel. And if you don't have still our application, you can get the 14 days free trial version if you fill in the form on our webpage. In the section free trial, you can see on the right part of the window, and all informations, all resources like tutorials for fire resistance you can find in our resource center. So you can looking forward to ongoing webinar focused on the connection design, balcony console imported from a robot. The webinar will take place on 26 February 2020. So I think that's all from our side. Have a nice day and bye bye.
Thank you. Bye.